And here, like talking about model prediction platform and this particular case. So for me, it's okay. What I would expect or assume, but quite likely wrongly, I would assume that the model quite likely was a kind of web service. So if there is a spike, I also would assume that you are running it on some cloud provider, so you can out of the box auto scale the endpoints. And when it comes to predictions, yeah, like why was it problematic? But maybe those assumptions are just wrong.
Yeah, there's a couple of nuances around model prediction that is different than a typical traditional microservice. And a couple of those things are, for example, depends on how you architecture it in terms of feature fetching, right? And model prediction, you need features in order to perform predictions. So who does the feature fetching? Is it the client side or the server side, right? So you have options on those. The client side, the cost of that is you have to send all those features over the network. Versus the server side, it can perform model feature fetching based on the clients, and it's closer to the server. And also the client side wouldn't have to be worried about all the complexities of fetching those features. So our model performance or prediction platform, it's about fetching features on the server side. Because we can do it centrally, we can do it more optimally, we can do it more efficiently, and easier for our clients to use our model prediction service.
So otherwise, like, do I understand it correctly? Otherwise, the features will be pulled, collected by my mobile app, and then sent to a model? Like, client in this context, what is the client? Server,
Yeah, the client is actually the logistics platform, not the actual consumer, but the upstream service, the product service that are customers of our model prediction platform.
Why are the servers closer to the features? Because you can deploy your then clients also close to the features, right? Or am I missing something in this puzzle?
Actually, you can, in terms of deployment, you can control where you want to deploy, either co-locate or whatever that is. And I think the biggest advantage is it makes it extremely easy for our upstream service to integrate with our model serving platform. All they have to do or worry about is defining features and tell our platform, hey, by the way, also uploading to our feature store. So the client team don't have to be responsible for all the nitty gritty infrastructure of managing those uploads. We do that on our behalf. We manage the feature store, in this case, on behalf of our clients. So all the clients or upstream services need to do is just use our library, specify what model they want to perform predictions on, only send the necessary features as part of that request, and then everything else will be taken care of by the platform side.
If it is not a secret, can you share with us what is the order of magnitude of requests for predictions, let's say, on Friday evening in the US?
Yeah, Friday it's probably the heaviest traffic, I think, in terms of traffic pattern wise. For all kinds of
it is the time when I have my pizza, so that's why I'm asking.
Yeah, I don't have that granular details in terms of the volume at certain hours. What we do know, and it's already published in one of the blogs, is and we track it also every week in terms of the weekly volume of predictions. And currently it's, I think daily we're probably doing 20 plus billion daily across all the use cases at DoorDash. And so our model prediction platform is like one of the largest services at DoorDash.
Let's say you have some traffic on Thursdays evening. So is it double or triple on, let's say, Fridays evenings? And in this case, how do you manage all of the scaling, right? How do you scale your services? Is it cloud? Is it on-prem?
Oh yeah, DoorDash is on the cloud, and so yeah, over the last, I don't know, 6 to 9 months now, we've been focusing on like how to make the scaling, how to make our platform more efficient. Because the moment you operate at scale, right, small gain will become very, very impactful in terms, because it's over every day, right? So we've been applying like auto scaling techniques based on the traffic pattern. The traffic pattern is pretty obvious, right? So we scale up based on the traffic pattern. We scale down when the traffic dies down quite a bit at night. And that's one of the ways for us to be more efficient at cost and other things. So this kind of comes down to not so much about machine learning anymore. It's all about how are you managing large scale microservices. So those techniques are very common.
Is it only microservices, or do you also have some streaming use cases? Because when I was kind of also working in e-commerce, it was e-commerce, but it had very similar problem where you would have to scale up in weekends and scale down during the week. But the most difficult problem was in streaming services, because it's really hard to scale up and down streaming storage. Do you have any examples of this, or was it only microservices?
Yeah, in our case, it's not streaming. When you say streaming, are you talking about like streaming content or streaming?
No. So it's just streaming platforms. Like, for example, you're collecting web traffic, right? So this is probably these events are probably hitting Kafka clusters or Kinesis or PubSub or something similar, right? And then the storages themselves, streaming storages, are very hard to scale down and up. So I was wondering, maybe you have some real life examples of how you would do that.
Yeah, in our case, it's all about like model prediction. So it's more on the microservices rather than the streaming platform, like you mentioned. You're right that for streaming, it's just not as easy in terms of doing auto scaling based on the traffic pattern.